Yes.
Can you go to the previous slide?
SF4 وهذا P4 S10. Yes.
Can you go to the previous slide to include the solution of the recording? Okay, thank you, doctor.
Okay. Nitrogen trifluoride, so this one, and dinitrogen tetroxide, and this one is SF4, and this one P4S10. Good. All right. Now, these are not important. What are the important? One are the three that I want you to know. What's this?
Ammonia.
You know ammonia, right? NH3.
Yes.
And nobody says nitrogen trihydride. That's the molecular name. But did you ever hear anybody saying nitrogen trihydride? Nobody. Everybody says ammonia. How about this one? What's this?
Water.
What's the molecular name for it?
Dihydrogen.
Hydrogen oxide. Okay. And I want you to know, in addition to this one, because this is important, what's this compound? What's the molecular name for it?
Dihydrogen sulfide.
Sulfide. But this was very important gas in industry, especially for oil industry. It's bad gas, by the way, they don't like it. Okay, and they say it without the di. So it should be dihydrogen sulfide, but nobody's using that. Everybody's saying hydrogen sulfide. These are the only three that I want you to know and know extremely well. Is this clear?
Clear.
Yes.
Now, what's the meaning of acid?
That includes H hydrogen.
H in where?
A compound with an
Gives what?
ion.
In water.
It gives H plus in water. That's important. It gives H plus in water. That's acid. Is this clear? Good.
Yes.
Now I want you to look at this table very well. First, let's start with HF gas. What's the name of this compound as gas?
Hydrogen fluoride.
Hydrogen chloride. No mono, no nothing. Now, when you put this in water, it becomes HF aqueous. And how do we call it? We call it hydrofluoric acid. Okay. What is this?
Hydrogen chloride.
Hydrogen chloride.
Gas. Hydrogen chloride gas or hydrogen chloride is enough. Okay. What is this?
Hydrochloric acid.
Acid. Good. Same thing with what's this as a gas?
Hydrogen bromide.
If it's acid.
Hydrobromic acid.
Hydrobromic acid.
Hydroiodic acid. And this one, which group is this one?
Polyatomic.
It is, what's the name of this group?
Cyanide.
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 We also treat it like the other elements in the halogens. So we call it hydrogen cyanide or hydrocyanic acid. I want you to be careful now. What's the name of this acid? One more time. Hydrochloric acid. Right? Now, let me ask you about this group. What's this group?
Chlorate.
Chlorate. Okay, it becomes HClO3. What's the name of the acid?
Chloric acid.
You change 8 into
Ic.
Only, you don't do anything else. So the name is chloric acid.
Do we do that with all the polyatomics?
Everything, yes, exactly. I will give you examples. But look here, I don't use the word what?
Hydro. But why?
Hydro. I use hydro, this is by agreement. I use hydro only for the original element, if it's the halogens and cyanide. Only. The rest, you have to change 8 into ic. And if it is ClO2 minus, what's the name of this group?
Chloride.
Chloride.
Chloride. And if it's ite, you change it to what to make it acid?
OUS.
Os. So what's the name of this acid?
Chloros.
Chlorous acid.
Rus acid. See, these are three. They are very related, but they are different acids. This one is called hydrochloric acid. This one is chloric acid. This one is chlorous acid. We also know this one. Which group is this one?
Perchlorate.
Perchlorate.
What's the name of this acid?
Perchloric acid.
Perchloric acid. I just
Doctor,
8 into it.
Doctor,
Yes.
can we treat cyanide like the polyatomic?
Well, yes. It's a special case in this case only here, only. That's why we call it, I mean, if we call it like, I mean, if it's cyanide, we should say there's no 8 in it. And that's why we deal it like chloride and bromide. And that's why we change ide into hydrocyanic acid.
And we can't say only cyanic acid, right?
No, we can't say cyanic acid. No, we have to say hydrocyanic.
Okay, thank you.
Okay, what's this group? What's this group first?
Hypochlorite.
Chlorite. What's the name of the acid?
Hypochlorous.
Chlorous. Exactly. The acid, which is this one, is called hypochlorous. I changed it into us. Okay, any other question?
Doctor,
Yes.
the hydrogen name, we only use it with this 5 in the table.
Exactly. Not hydro, we don't say hydrogen. Hydrofluoric acid, hydrochloric acid, hydro and so on.
هذا نستخدمها بس مع شو اسمه اللي في التيبل.
مع الهالوجينز.
الهالوجينز.
اصلا موجوده في البريد تيبل ما عدا الساينايد. الساينايد هو اللي نستخدم معاه هيدروساينيك اسيد.
Doctor, what do we do with the other polyatomics?
Same thing. If anything, if you have anything with 8, change it to ic. If it's ite, change it to os. That's it. But you have to memorize table 2.3 very, very, very well. Don't forget it.
So, Doctor.
In any acid, you change 8 into ic and ite into os. Okay? Okay, so if we make the acid of this one, what's the name of this group?
Sulfide.
Sulfide. So if I make this acid, what's the name of this acid?
Sulfurous acid.
Sulfurous. I just change ite into os and then write acid. Why did I put 2 here?
2 negative.
To balance the charge.
Balance.
Exactly. Okay, good. Now, this part is not required from you. Don't memorize anything in 2.7. Clear? Neither this table is not required, even though you have it in high school. What's this? Methane. You remember methane, ethane, propane, butane, pentane, pentane, hexane, heptane, octane, nonane, docane, but not important in our case in this course. Clear?
Yes.
This is
Yes.
required in this course. Not required in this course. Okay. Functional group. This is not required as except in the table. I want you. This table is required. It's not required, but I want you to know this one. Forget about it completely. It's not required. But this one, I want you to know anything organic compound. What's organic compound? Means there is carbon in it. If there is hydroxide attached to it, then we call it alcohol. Give me example. C2H5OH. What's this? This is called ethanol, which is alcohol. All right? Okay.
Acetate, I think.
Huh?
Acetate.
No, it's not acetate. It's alcohol. And we end up with ol at the end. Okay? Now, I just want you to know if it's OH, then it is called alcohol. That's it. Now, if it is COOH, or like we sometimes write it CO2H. And the best way to write it is to write it C double bond O OH. All of these 3 forms the same. If we have anything bonded to compound, then we call this carboxylic acid. Carboxylic acid. The most famous one is CH3COOH. What's this? This is called acetic acid. ايش الكوميرشال نيم؟ الفينيجر، الخل. All right, the vinegar is acetic acid. This is when you see this group COOH, or sometimes they write it CO2H, or the best way is to write it C double bond OOH. See, this is COOH. That's the true structure. But you don't have to know it. But this is now acid. Clear? The last group, when you have organic compound bonded to NH2, this is called amine. Amine. And it is what? Base. So this is acid. What's this?
Base.
Base. And this one is?
كحول.
Is what?
Neutral.
Neutral. What do you mean by neutral?
Not base and not acid.
Not acid and not base. I hope you know this. That's the only thing I wanted to know here. Okay, then now next I want you to know this. Empirical formula, important. What's the empirical formula? Empirical formula means simplest formula. Empirical means simplest, but not true. Okay, example. Look at water, H2O. It's H2O, and if you want to make it simpler, we cannot. It's H2O. But look at H2O2. This is hydrogen peroxide, H2O2. Can we make the structure? This is the true structure. It's 2 oxygen with 2 hydrogen bonded to it. Can we make it simpler? Yes, we can write it HO as simpler. That's called empirical formula. It's not the molecular formula, it's not the true formula, but it's called empirical, simplest formula. Clear? How about C2H6? Can we make it simpler?
Yes.
How?
We remove the 2 and put in 6 3.
How about
Divide by 2.
C3H8? How about C3H8? Can we make it
No.
simpler?
No.
No.
No. How about C2H2?
Yes.
Yes.
But
How about C6H6?
Yes.
Yes.
I want you to notice here, even though this one is C6, CH, and this one CH, but they represent two different things. So the empirical formula does not represent the real structure. The real structure is represented by the molecular formula. And this is the real structure for C6H6, and this is the real structure for C2H2. Is this clear? Good.
Yes.
Make the empirical formula for this compound. What's the empirical formula for the first one?
CH2O.
H2O.
And
H2O.
how about second one?
CHN.
How about third one?
The same.
Exactly. Very good. Okay, so this one, 2.8, is also not required. Okay.
All of it?
These are some questions I gave you. Name the following binary compounds. What's the name of this one?
Nitrogen trifluoride.
Nitrogen tri, because it's non-metal with non-metal. Fluoride. Good. How about this one?
Nitrogen tetroxide.
Nitrogen tetroxide. Good. Name these compounds.
Magnesium oxide.
Magnesium.
Magnesium oxide. What, you did not say mono or anything, right?
Yes.
Yes.
Okay, how about the second one?
Aluminium.
3.
Aluminum.
Aluminum.
What?
3.
Hydroxide.
Hydroxide.
Hydroxide?
No, we need to use the Roman numericals, right?
No.
Directly hydroxide.
Did I write 3 here?
No.
Why not?
Because aluminium have only
It's in group 15. One oxidation number.
Main group. So you keep it as it is, and you write here hydroxide. That's the only thing that you write. Hydroxide, the name of this group. Okay, third one.
Iron 3 sulfate.
Say now 3 because it's transition metal. Iron 3 what?
Sulfate.
sulfate.
Sulfate, exactly. I hope you know how to do it. Good. Okay, name these compounds.
Mercury 1 chloride.
The first one here, Hg2, this is a special group.
Mercury.
Again, table 2.3, don't forget it. Table 2.3, you must memorize very well. What's the name of this group? From the table.
Mercury 1.
Mercury 1. And that's why, what's the name of this compound?
Mercury
1 chloride.
Mercury 1 chloride. Good.
Why not
Second
2,
one.
doctor?
Huh?
Why not 2 mercury 2?
Because it's a special group. Go to table 2.3.
Ah, okay. Sorry, yeah, right.
Okay. How about second one?
Lead 2.
Lead. And lead is not transition metal, but it has more than one oxidation. That's why we should put which oxidation we're talking about. And we're talking about lead 2, and then what?
Chromate.
Chromate, we get it from table 2.3 again. And we know what's the charge of chromate?
-2.
-2. That's why the lead must be +2. Clear?
Yes.
Okay, last one. C, what's the name?
potassium,
potassium.
hydrogen,
هذه special group from periodic table. From table.
Hydrogen phosphate.
hydrogen phosphate,
hydrogen phosphate.
Hydrogen phos. What?
phosphate,
Phosphate.
Yeah, this is the name, hydrogen phosphate. And the charge in it is -2. That's why it take 2 potassium. I hope this is also clear.
Doctor, in this case, we can't say it is acid, right?
No, it's not acid.
Okay.
This is salt, actually, milk. Okay, what's the name of the first compound?
Hydrogen chloride,
Hydrogen chloride. Can I say hydrochloric acid?
No, it's gas.
Oh,
No, because it's gas.
gas. Good. What's the name of B?
Hydrogen chromate.
No,
chromic acid,
just simply chromic acid. Exactly. Why? Because the name of this group is chromate. And you change 8 into ic. Simply acid. Clear? Okay.
Clear.
What's the name of the SO3 group?
sulfurous acid,
Sulfurous acid.
Sulfurous acid.
What's the SO3 2 minus? What's the name of the group?
sulfite,
Sulfite.
Sulfite group. So what's the name of this acid?
sulfurous acid,
Sulfurous acid. Why did you say sulfurous?
because it is it.
Okay. How about D? What's the name of this compound?
Iodic acid.
Iodic acid.
Wrong. It's not iodic acid.
Hydroiodic.
Hydroiodic acid,
Hydroiodic acid. True. What is that? Somebody just said just a while ago. What's the name of this compound?
iodic acid,
Iodic acid. Iodic acid, which is
Doctor, what
the
do you
same
put
got
here?
hydro. Okay. Okay.
Doctor,
Last-
why did we put hydro here?
We said this in the table. You remember the table?
Oh, yeah.
Okay.
Oh, yes.
All right. Okay, good. Okay, last one. What's this group called?
phosphoric acid,
Phosphate.
So phosphoric acid.
Phosphorus.
phosphoric,
Phosphoric acid. So you change it into it. This time you add also O. Clear? And with this we finish. Now I have some problems also to solve very quickly, inshallah. Okay, this back. Okay, good. All right. If the temperature is 39 C, can you change it to Fahrenheit? What should you do?
Yes.
Time by or multiply by 9/5.
9/5 plus 32.
Give me the answer quickly.
102,
102.2.
Exactly. Good. Good. I have this good question for you. We know that in what's this called? scale. What's the scale called?
Degree
Celsius.
C.
Celsius degree.
Celsius or
C.
degree. Okay. What about this one?
Fahrenheit.
Fahrenheit.
What? Fahrenheit. Fahrenheit, and this is Celsius. Let's assume that I made a new one. I made it myself. It's called degree A. And I have degree A here compared to degree C. And when degree A is 0, I found that actually degree C was exactly minus 45. And when degree A is 100, degree C was 115. Now, can you convert 80 degree A into C?
Yes.
How? Let me help you. Let me help you. First, to do this, first find what's the range here. What's this range? From 0 to 100, what's the range?
100.
Good.
From here to here, what's the range?
160.
160. So 100 in A is equivalent to 160 in the centigrade. Clear?
Right.
Right. Okay.
Yes.
Why? If I want to change A into C, degree C equal to degree A, I will multiply it by 160 and divide by 100, which is the range. Okay? And then I have to subtract minus 45. Why? Why did I subtract minus 45? Because let's apply whatever is written for us here in here. If A is 0, then what will be C?
Minus
Minus 45.
Correct. Okay. If A is 100, what will be A? Apply it here, apply it in the equation.
115.
115.
100 what? 15. Because it will be minus 160 minus 45. So the conversion, this equation that I just made, is absolutely true. Apply it now for 80. What is it going to be for 80?
83.
Exactly. How, do you see how you can convert from one scale to the other? So you should take the range and multiply and divide by the range, and then the 0, you have to change it to the number that is given to you. I hope this is clear. Good. Let's calculate this one very quickly. Give me the answer for the first part, which is this one. Use significant figures. What's the answer?
$235.2.
35.2. Give me something else.
It's actually 15. It's 15 actually.
15 exactly.
Yeah.
Yeah. But with the significant figures, it will be two.
Very good, very good, very good. So that's what I got from my calculator. Is this the right number from significant point of view figure?
No.
No, we need
No.
only one after the decimal.
After the decimal, I should have only one. That's not acceptable. It should be 235.2 from significant point of view. Good. How about multiply these two together and give me the answer very quickly.
112.93.
93. Give me more. 93 what?
Which is
928.
928.
0, but it's 5
920.
significant.
Very good. This is the answer. Is this correct from significant point of view?
No. It should
No,
be
no.
5.
We need only 5 significant.
Only 5.
Count everything here. How many here?
5.
5.
How many here?
5.
5.
Your answer should be what?
5.
This is
5.
wrong. It should be 112.9.
93.
Good. Now divide this one by this one. What's your final answer?
2.0827.
8 what?
27.
27. Very good. Is this a correct answer?
No,
Oh,
Why?
it should be 4 significant figures.
Only
Here,
4.
5 here. This should be 4. So I should take this away and make it 3.
So Doctor, we take the least significant figure.
Huh?
We take the least significant figure.
Least, you mean?
Least, yeah.
Yeah. Good. Good. Let's solve this problem very quickly. If you have 2,400 milligram, and I know that 1 pound equal to 453.6 gram, can you convert this milligram into pound?
Yes.
Use conversion factor. What should you do?
Divide by 1,000.
1 times 10 to the power 3 what?
Milligram.
milligram.
Equal to what?
1 gram.
1 gram.
Gram. And then the other conversion, what should I write at the top or the bottom?
Divide by 453.
453.6.
Then,
1 lb.
and this is gram will go with gram, milligram will go with milligram, and you have the answer. Give me the answer very quickly.
1 over A, 189.
What again?
1 over 189.
Yeah, give me the answer, final answer.
5.28 times 10 to the power minus 3. It is 29. 29.
29, no problem, 29, better. Okay, but this is what I want. And now I don't care about significant figures, by the way. Don't worry about significant figures. Okay, so yes, but I want you to know how to get rid of units. Good. Let's solve this problem very quickly. The mass of electron, mass of hydrogen atom, the mass is this. And the radius of the hydrogen atom is 53 picometer. And to calculate the volume equal to 4 over 3 by R cube. What's picometer?
10 to the power minus 12.
What?
Meter.
Meter.
Can you calculate the volume in meter cube? Quickly, give me the answer.
6.23 multiplied by 10 to the power of minus 51.
Okay, it's actually what you should do, 4 over 3 by times 53 times 10 to the power minus 12 meter all cube. And the answer is absolutely true, which is 6.24 times 10 to the power minus 31 meter cube. Give me the density in kilogram per meter cube. Come on.
2,676.28.
7 times 10 to the power
2.
Yes.
3.
I'm sorry, 3.
That's it. 7 times 10 to the power 3 kilogram per meter cube. Okay, good. I want you to give me the same answer in kilogram per liter. What should you do?
Dividing by 1,000.
Meter cube, 1 meter cube equal to what? How many liters?
1,000.
1,000.
Exactly, 1,000 liters. So what's the answer?
2.7.
2.7. That's it.
2.7.
Very good. Okay, excellent. Okay, now this is the last problem we have. You know, remember the law of definite proportion, multiple proportion?
Yes.
Law of multiple proportion. We have here two compounds, compound A and compound B. In compound A, the amount of X in it is, the amount of Y, everything is given in Y. The Y in compound A was 50%. And in compound B, it was 60%. And we know that compound A structure is X, Y, 2. X, Y, 2. The question is, what is the structure of compound B? What should you do? If this is 50%, what is X?
50%.
50% also.
How about if it's 60%?
40.
40%.
The two different compounds. Good. Now, do you remember the law of multiple proportion? It says that the amount of Y that should react with 1 gram of X. So I want to make this as 1 gram. Then what will be Y?
Also 1.
It will be 1 gram. Okay. If I make this one also, I want to know how, if it's 1 gram, then what will be Y in this case?
1.2.
1.5.
0.5 gram. Good. The law of multiple proportion says that the amount of Y that will react with 1 gram of X compared to the amount of Y that will react with 1 gram of X in compound B must be a simple ratio. So this 1 gram to this 1.5 gram must be simple ratio. Let's have it 1 to 1.5. Can you make it simpler?
2/3.
2/3.
2/3. So the Y was here 2 compared to 3 here, if it reacts with 1 gram. So what's the structure of compound B in this case?
XY3.
So you found what's the structure of compound B, which is XY3. Is this clear?
Doctor,
Yeah.
can you explain it quickly again?
Okay, no problem. As I said, first we start with 50-50, we make it 1 gram, 1 gram, right?
This is from us. We decided this.
No. It says here, in the first compound, first one, which is A, the percent mass of Y was 50. So this is 50-50. If it's 50, it must be 50, right?
Yes, right.
It's 1 gram to 1 gram. In the second compound, Y was what?
60.
60. So what will be X? 40. عشان يصيروا 100%.
Oh, yes, okay.
Okay, عشان 100 و100, right?
صح.
Also, I want to change it to 1 gram, 1 gram. I want to change this also to 1 gram. If I make this 1 gram, the 40 change it to 1 gram, what will be the Y?
1.5.
1.5, because 40 60 على 40 1.5.
صح.
Now, the law of multiple proportion says that if the amount that will react with 1 gram of the amount of Y that will react with 1 gram in X compared to the amount of Y that will react with 1 gram of X in the second compound must be simple ratio, which is, in this case, I will put 1 to 1.5. 1 to 1.5 is not simple ratio, I want to make it 2 to 3. Since this one is already XY2, because it says here, if the first compound is XY2, then what must be the formula for second compound? It must be XY3 لأن احنا جبنا الثلاثة من هنا زي جبنا اثنين من هنا والثلاثة من هنا. واضح؟
Yes, it's clear.
دكتور
يس
من وين ألقى هذه السلايدات اللي فيها أسئلة؟
موجودة، أنا أحطها لكم في البلاك بورد كلها موجودة.
تمام شكرا.
اوكي حياكم. اوكي الان بسكر هذا وبروح للتحضير. انتهت المحاضره، ما عندي شيء اضيف اضافه. خلينا بس نسوي التحضير قبل ما نمشي ونتوكل على الله ان شاء الله.
الله يعطيك العافية يا دكتور.
لا تمشوا الا لما نسوي التحضير.
أبشر أبشر.
Let me stop recording also.